Need to expose your REST API to AI models without rewriting everything from scratch? We'll use FastMCP's OpenAPI integration to automatically convert an existing API specification into MCP tools and resources. You'll see how just 3 lines of setup, fetching the OpenAPI spec, configuring an HTTP client, and calling from OpenAPI, can instantly make your entire API callable by AI models, complete with proper parameter handling and authentication support. Import HTTPX. From FastMCP, import FastMCP. Create an HTTP client for your API. Client equals HTTPX. Async client base URL equals https://API, example, com. Load your OpenAPI spec. OpenAPI spec equals HTTPX, get. https://API, example, com/OpenAPI JSON. Create the MCP server. MCP equals FastMCP from OpenAPI. OpenAPI spec equals OpenAPI spec. Client equals client. Name equals my API server. If name equals main. MCP run. This demonstrates the API gateway pattern through automatic protocol translation. The code bridges REST APIs and the MCP protocol by dynamically converting OpenAPI specifications into AI-callable components, creating a universal interface layer between existing services and LLM clients. The pattern works by treating the OpenAPI spec as a declarative contract. FastMCP analyzes endpoint definitions, HTTP methods, and parameter schemas, then maps them to appropriate MCP component types, tools, resources, or templates, while preserving the original API semantics. The HTTP client handles transport, while the framework manages protocol conversion, parameter validation, and response formatting. This approach solves the integration tax of exposing legacy APIs to AI systems. Instead of rewriting endpoints or maintaining parallel implementations, you create a single translation layer that preserves existing infrastructure while enabling modern AI interactions. The trade-off is some abstraction overhead, but it eliminates the need for API-specific client libraries or manual tool definitions. Let's break it down. Import HTTPX. From FastMCP, import FastMCP. This imports HTTPX for async HTTP requests and FastMCP to create an AI-callable API server. HTTPX handles the underlying API communication, while FastMCP bridges Python functions to AI models using your OpenAPI spec. Create an HTTP client for your API. Client equals HTTPX. Async client base URL equals https://API, example, com. This initializes an async HTTP client with a persistent base URL, eliminating the need to repeat the full API endpoint for every request. The connection pooling and keep-alive handling improves performance for multiple API calls, which is critical for FastMCP's proxy operations. Load your OpenAPI spec. OpenAPI spec equals httpx get https://API, example, com/OpenAPI JSON. This fetches the OpenAPI specification from the target API, which defines all available endpoints, parameters, and schemas. FastMCP uses this spec to automatically generate type-safe tool interfaces, eliminating manual endpoint configuration. MCP equals FastMCP from OpenAPI. OpenAPI spec equals OpenAPI spec. This initializes FastMCP using the OpenAPI specification as a blueprint. The spec defines all available endpoints, parameters, and schemas, ensuring the mock server precisely mirrors the real API's behavior. This is the factory pattern for creating API-compatible mock servers from OpenAPI specs. If name equals main, MCP run. This is Python's standard entry point guard. It ensures MCP run only executes when the script runs directly, not when imported as a module. Without this, importing the file would unintentionally start the server. OpenAPI to MCP conversion. This pattern bridges REST APIs and AI models by transforming OpenAPI specs into MCP components, with each endpoint becoming a callable tool by default. The route mapping order matters. First match wins, so arrange your route maps from most specific to most general. Always validate your OpenAPI spec first, as malformed specs silently create broken MCP servers.
The specification that describes everything becomes nothing when the server starts listening.